In this video, we're going to discuss when functions are increasing, decreasing, or constant. So let's start with increasing. A function is increasing on an interval if for any x values in the interval, the larger x value gives a larger y value. So that's what this is saying here. Remember, f of something is telling you about an output or a y value of the function. So this is saying that the function value or the y value associated with x1 is smaller than the function value or the y value associated with x2. So what this is saying is a larger x value gives a larger y value. Now if we think about this on a graph, the x values get larger as we move to the right. So this is saying that as we move to the right, the y values will get larger. So it will look something like this. The y values are increasing as we move from left to right. Similarly, a function is decreasing on an interval if a larger x value gives a smaller y value. So here, x1 is still denoting our smaller x value, and x2 is denoting our larger x value. So this time, we see that the larger x value is giving a smaller y value. Now again, a larger x value, as x values get larger, that means we're going to the right. So this is saying that as we move to the right, the y values now are getting smaller. So we might have something like this. All right, so those are two possibilities, and the third possibility for a function's behavior on an interval is that maybe the function is constant. So this is saying a function is constant on an interval if for any two x values in the interval, their y values are the same. So if all of the points in the interval have the same y value, that's going to look something like this. So it's going to be part of a horizontal line. Notice how when we're talking about this interval where this happens, we're talking about x values being in the interval. So when we discuss where something happens for a function, the location, the where, is always referring to the x values. And the reason for that is because we know that the x values will be unique for a function. Remember that each input, each x value, gives only one output. So this means that you won't have 2 points on your graph with the same x value. For example, you wouldn't have 2 points on your graph with an x value of 5. It just won't happen because it's a function. The y values don't have to be unique. We just saw right here a bunch of points with the same y value, but that is a function because it passes the vertical line test. Here's an example of why it might be confusing to use the y values instead of the x values. So let's say this is our function graph here. That point there labeled with a dot is at 0, 2. So if we look at where this function is increasing and where it is decreasing, Remember, increasing means that as we move from left to right, the y values are getting bigger. So as we move from left to right, the graph goes up. That happens on the right half of the graph. So over here, the function is increasing. Right? And then decreasing means that as we move from left to right, the y values get smaller. So as we move from left to right, the graph will go down. So the left half of this graph is decreasing. So if we want to describe with an interval where the function is increasing or decreasing, it would not make sense to use the y values. If we look at the y values on the part that's increasing, the lowest y value is 2. And then from there, the graph increases without bound, so we would use infinity at the other end of the interval. If we look at the y values on the left side, where it's decreasing, again, the lowest y value is at that point with a y value of 2, and then we don't have a highest y value. This left piece of the graph goes up forever. So if we use the y values, we get the same interval because the y values can show up multiple points on the graph. So we don't want to use the y values because that's too confusing. If I'm asking you for a location and you give me a location, I should be able to find it on the graph. But in this case, it's hard to distinguish which piece is increasing and which piece is decreasing using the y values. So instead, we would want to use the x values because each x value will only show up once on the graph. So if we wanted to describe the part that's increasing using an interval of x values, the smallest x value would be at the left end of that piece. So that piece starts right here at an x value of 0. And then from there, it goes forever to the right if we're following our x values. So we would put infinity at the right end. If we want to describe an interval where it's decreasing, at the left end, if we follow this decreasing part to the left, it's just going to keep going forever to the left. So we're coming from negative infinity, and then again, that point 0.02 is where it stops decreasing. So this is how we would identify intervals where the function is increasing or decreasing. Notice how these are open intervals, meaning the endpoint is not included. So we have parentheses. That's always the case. And the reason for that is because if we look at that point, 0.2, we can't just look at a single point and say that it's increasing or decreasing. If I have a graph and I just look at one point, the graph isn't going anywhere. If I'm staying at this one single point, the graph isn't going from left to right, so we can't talk about whether it's increasing or decreasing at a certain point. So if we include the endpoint, we're saying that at a specific point it's increasing or decreasing, but that doesn't make any sense. Also here, which piece would it make more sense to include the 0 with? The left piece, the right piece, both? So it's always open intervals that we use to discuss where a function is increasing or decreasing. So let's practice identifying some more where a function is increasing, decreasing, or constant. So again, increasing means that as we move from left to right, the y values get bigger, which means that the graph will be going up. So on this graph, that happens right here. That's the part that's increasing, going up from left to right. And again, we want to use the x values to identify this interval. So it's coming forever from the left because of this arrow here. It's coming forever from the left. So we're going to use negative infinity. And then at the right end, we're at this point with a x value of negative 2. So we would say that this function is increasing on the interval from negative infinity to negative 2. And again, we're using open interval, which means parentheses here. Right, if we look for where this function is decreasing, decreasing means going down from left to right. So this piece of the graph is decreasing. It's going down from left to right. If we look at the left end of this interval, we're at an x value of 3. And then if we look at how far to the right it goes, it keeps going forever to the right. So we use positive infinity. Remember that in the x direction, positive infinity means going to the right forever. Negative infinity means going to the left forever. And we are looking at the left-right direction, not the up-down direction, because we're looking at x values, not y values. All right, then the middle portion of this graph that's not highlighted, that is our constant portion because it looks like part of a horizontal line. So we would say that this function is constant on the interval from negative 2 to 3.